we're gonna keep going. All right. Our next one is 50 and 80. Now, y'all remember what I said last time? I told y'all this is my favorite one. What did I say? When two numbers end in 0, what can they automatically be divided by? 10, that's right. So, I know that I'm gonna put 10 on this side because 10 is not a prime number. Remember, you want your prime number to be hanging off of a branch with no other branches connected to it. So what times 10 gives me 50? Is it 4? No. Is it 7? No. Is it 5? Yeah, it's 5. It's 5. So 5 is a prime number. I'm done with 5. At least not done, but I'm done with that little section. 5 is a prime number. I do not need to factor it out. 10, however, is not a prime number. Something else can be multiplied together to give me 10. What can I multiply together to get 10? If you said 2 times 5, you are right. 2 times 5 is correct. Now, 2 and 5 are both prime numbers. So, we're done factoring out 50. That was easy. We just had to basically split it up and try to get prime numbers. So now we have to do 80. If you can tell, 80 is going to be a little bit longer, okay? So we're going to do, just like how we did on that side, if it ends with 0, it can be divided by 10, or it can be, we can multiply 10 to get the answer. So I'm going to just write 10 on this side because that's what I did on that side. But what can I multiply 10 by to give me 80? If you're saying 8, Miss Soto, 8. You're right, it is 8. Now, if you see here, I already have 2 branches ready because 8 and 10 are not prime numbers. They can both be factored out 1 or 2 more times. So if I factor out 8, I want to write a multiplication fact that will give me 8 besides 1 and 8. So what else can I multiply together to give me 8 besides 1 and 8? If you said 2 times 3, you're wrong. That gives us 6. It's 2 times 4. And then I need to factor out 10 before I can move on. So we already did it in the problem. What can be factored, what can be multiplied together to give me 10, y'all? 2 times 5. That is right for those of you who said it at home. But we are not done. As much as y'all probably like, Miss Soto, can we be done with this problem already? Listen, same. But we got to finish it out. So there is a branch right here with 4 because 4 is not a prime number. Our goal, remember, is to make all of the numbers remaining at the end of the branches to be just prime numbers. So what can I multiply together to give me 4 besides the numbers 1 and 4? What else can I multiply together to give me 4? The answer is 2 times 2. So now we're done because 2 is a prime number. Now, if you are like me and you see that the numbers are kind of getting closer and they're kind of like confusing your eyes, I do suggest drawing a line in between your numbers so you don't get like your brain jumbled up because all of the numbers are really close to each other and it hurts your brain because it hurts my brain. So if you need to do something to make your life easier, draw a line in the middle. And you can do that for the rest of them, all right? Do whatever helps you the best. So now that I've drawn the line down the middle, I'm gonna go and circle all of the factors that they have in common, okay? So I'm gonna start at the bottom. They both have a 2 in common. they don't have another 2 in common, but they also have a 5 in common. And then they don't have another 5. So the only factors that they have in common are 2 and 5. They have the same numbers, they have the same amount of 2's and the same amount of 5's on both sides. So that means my GCF, I was about to say GPS, y'all. Woo, Lord. My GCF is 2 times 5, which is 10. So our greatest common factor of 50 and 80 is 10. All right, now to number 5. On number 5, we have 18 and 28. So, let me do this. I'm going to draw a line down the middle, like how I said to do on number 4, just because my brain hurts sometimes, and it happens. So now, 18 and 28. I want to first factor out 18. So since 18 is even, I'm automatically going to do, I'm going to do 2 times the number to give me 18. So I know 2, and if I know my facts, I know 2 times 9 gives me 18. But now, if you see here again, there's not a branch underneath 2 because 2 is a prime number. So we have to figure out, okay, well, 9 is obviously a prime number because there's more than one factor that can go into it besides 1 and 9. What else can I multiply together to give me 9? Is it 2 times 4? No, that gives me 8. Is it 3 times 4? No, that gives me 12. It's 3 times 3, right? Yeah, that's right. 3 times 3. And then 3 is a prime number, so we're done factoring out for 18. Now we're going to go to 28. Again, 28 is an even number, so I'm going to start off with 2. Now, some of us may not know this at the top of our head, but what we can multiply 2 by to get 28 is 14, okay? Some of us probably did not know that at the top of our head, but this is a good time to memorize that, okay? So 2 times 14 is 28. 14 is not a prime number because there's another factor set that can be multiplied together to get 14. So, but I do know 14 is an even number. So I'm going to do 2 times. Now, what can I multiply together to give me 14? If you are thinking 7, the answer is correct. 2 times 7 is 14. So now, we want to circle all of the factors that they have in common. So I'm going to start at the bottom. They don't have a 7. They both have a 2. They don't have a 3. They don't have a 14. They don't have another 2. They don't have a 9. So, our greatest common factor, this one's pretty easy, is just 2. Because there's only 1 2 on each side. You're probably thinking, why didn't we multiply? The reason why we didn't multiply is because if you look, for example, on number 4, both sides have a 2 and a 5. Well, whenever we're factoring, we're trying to figure out the numbers that can be multiplied. So we're basically multiplying to get the numbers at the top. So however many numbers that they have in common on one side, that's when you multiply. So since here we have 2 numbers that they have in common, we multiply 2 times 5. But here, they only have 1 number in common. So the greatest common factor is just 2.